We're going to finish this series of videos talking about object references and pass-by value. So let's start with reviewing object and primitive references. So remember that Java stores primitives and objects differently. Java stores primitives right in place. So what's stored in the variable is the actual value. Remember that primitives are small pieces of information. It's a number or a single character or a Boolean like true or false. So this is a small piece of information that can be stored right directly in place. But object references or object variables are stored differently. So objects, as we now know, have a lot of information that describes them, right? For example, an audio item is described by a lot of things. It's described by a title and a price and a number of seconds. There's all this information that describes it. It's too much to be stored in one single place in memory. So what has to be stored there is a reference or a memory location or an address, sometimes called a pointer, lots of different names there, but it's all the same idea. The idea is that what's stored there is a reference to somewhere else in memory where all the information about that object resides. Okay, so again, primitives are stored right in place, but objects, what's stored in place of those object variables is a reference to somewhere else where there's a larger space in memory and all the information is stored. So this matters when we're passing objects as parameters. So what we need to keep in mind is what happens when you assign a variable. So when you assign a value on the right to a variable on the left, what happens is whatever value is in your variable on the right is assigned to the variable on the left. But if it's an object, what that value is a memory address. It's not an actual value. So that matters when we pass an object as a parameter, because remember when we pass an object as a parameter to a method, the formal parameter and the actual parameter, which is what we send in, become aliases. Okay, so let's take a look at what this means in a moment. One other note about object references relates to garbage collection. So when an object no longer has references that point to it, that means it can't be accessed anywhere by anywhere in your program, and that object is now referred to as garbage. It basically means there's somewhere in memory that there's no variable pointing to that location anymore. And so Java comes along and does automatic garbage collection every once in a while and cleans up those memory references so that that memory can be reused. This is one of the nice features about Java, is that this is done automatically. You don't have to manually go in and release memory. If any of you have experience programming in other languages where you do have to do that, it can be error prone. So this is a nice feature of Java that we don't have to worry about it. Java does it for us. So let's take a look at assignment here. Let's revisit what this looks like. So for primitives, again, remember what's stored here is the actual value. So if we have the variable num1 of type int, here it is in memory, and what's stored right there is the value 38. Here's num2. What's stored right there is the value 97. Now, if we have this assignment statement, num1 equals num2, what happens is the value on the right, which what's the value of num2? It's 97. It's the actual number. It's the data, because this is primitive. So this, whatever is stored here, which is this data, gets assigned to the variable on the left. So what happens here is the 97 gets stored in place of num1. And what the result is you get this, that num1 stores 97 and num2 also stores 97. But it's not one copy of the number 97, it's two separate copies. So if I were to now say, something like num1 plus plus, num1 would now store 98 and num2 would still store 97, because these aren't linked to each other. This is just basically a copy of the value gets taken from this variable and placed into this variable. Okay, so that's what happens with primitives. Now, the same thing happens with objects, right? What is stored in one variable gets placed in the other, but the difference is what is stored, right? So for a primitive, what is stored is the value, and for an object, what is stored is the address. So let's pretend we have two J buttons, one called click button and one called second button. So here we have a place in memory click button, and this is an object. So what's stored there is a reference to somewhere else in memory where all the information about a J button object is stored. Same thing for second button. What's stored is a pointer to somewhere else in memory where we have the whole object stored. And now if we have this assignment, click button, get second button, what happens is we take what the value of second button is. Well, what's the value of second button? It's this arrow right here. It's this memory address. And we basically copy this into click button. So we're taking this memory address and we're putting it into click button, which means basically click button and second button store the same memory address. So they both point to the same place in memory. Okay. So these two variables are now aliases because they point to the exact same place in memory. And this button that we had before is now ready to be garbage collected because nothing's pointing to it. So there's no way to access this place in memory anymore, so we can release it, or it can be released by Java. Okay, so an alias or aliases are two variables that point to the exact same place in memory. What that means is if we change something about this JButton object through the second button variable, if we say second button dot set enabled false, for example, it's going to affect click button too because they're the same object. There's not two copies of this object. It's the exact same object. There's only one place in memory where this information is stored, but we have two references that point to that place in memory. Okay, so that all leads us into talking about pass by value. So make sure that you understand this idea of how assignment works for primitives and how assignment works for objects before thinking about pass by value, because you need to understand that idea first. So if that idea isn't quite clear yet, then please post questions about that before moving on to this final topic of pass by value. So parameters in Java are passed by value. What this means is that when you send an input into the method, the value of the parameter that you send, the actual parameter, is what gets assigned to the formal parameter. Now for primitives, this is pretty straightforward, but it works the same for primitives and objects. The value is what gets assigned to the formal parameter. The difference is what that value is. For a primitive, the value is just the value, it's the data. But for an object, the value is the memory location. Okay, so let's take a look at how this works with primitives. It's pretty straightforward, and it's a little more complicated for objects. We'll come back to this in a moment. Okay, so let's look at a primitive example. So here we have a primitive variable n1. We'll assign it the value of 2, and then we have this method down here, double number. Double number takes one parameter of type int, and all it does is inside the method, it doubles that parameter, and then it prints it out. So in our, pretend this code here is in main. So we declare n1. We then invoke the double number method with n1, and then we print out the value. So let's trace through exactly what happens here. We have n1, and what does n1 store? It stores 2, because n1 is a primitive, and so it stores its value directly in place. Then we invoke double number. Now behind the scenes, anytime you invoke a method, what happens is the formal parameter, in our case numParam, is assigned the value of the actual parameter, in our case n1. So it's as if behind the scenes there's code that says numParam equals n1. That's true every time you invoke a method. It's like behind the scenes there's code that says formal param equals actual param. Okay? So this line is going to run, and what that means is we set up a place in memory called numParam, and it gets assigned the value of n1. Well, what is the value of n1? It's 2, so that means numParam is also now 2. So now we go inside the method and we execute numParam gets numParam times 2, so we've multiplied numParam times 2. When we print this out inside the double number method, numParam is now 4. When this method ends, any local variables as well as the formal parameters are garbage collected because these are local only to the method itself. And so when the method is over, those variables are lost. And then we return back to main and we print out n1, and n1 is still 2. So because these are primitive variables and because of how assignment works, when you take a primitive value and you pass it in as a parameter, the value is passed, and what that value is just the number. So numParam is assigned the same number, but that means any changes you make to that formal parameter inside the method, they're only kind of in effect inside the method because the actual parameter and the formal parameter, they're not linked in any way. It's just a copy of that value is placed into the formal parameter. Now, it works a little bit different with objects, so let's talk about that. Objects are a little bit trickier, right? Because they work the same way in that the value is what is passed to the formal parameter, but what is the value? Well, the value is a pointer or a reference to the place in memory that holds the description of that object. So that memory location is what is passed, okay? So now the formal parameter and the actual parameter become aliases of each other. They point to the exact same place in memory. So that means that changes made by methods invoked on the formal parameter will affect the actual parameter because they're the same thing. So a lot of people misinterpret this to mean that Java is passed by reference, but it's actually not. It's actually passed by value. The tricky thing is just what that value is. And for objects, that value is a reference to a place in memory. Okay, so when you pass an object as a parameter, again, the formal parameter and the actual parameter become aliases. And that means if you invoke some sort of method to change the internal state of an object on the formal parameter, you change it for the actual parameter too, because they're aliases. If, on the other hand, you take that formal parameter and you assign it to point somewhere new, now they're not aliases anymore. And so now any change you make to the formal parameter will not affect the actual parameter. Okay, so let's look at an example. And we're going to use the rectangle class. A rectangle is just a class provided by Java that represents rectangles. It has instance data, width and height, and it has methods get width, get height, and set size, where you send in the width and height. So it's just a basic class to represent a rectangle. Okay, so here we have our code. We declare a rectangle object with a length, width and height of 4 and 5. And we print out the dimensions. So this is going to print out the rectangle dimensions are 4 by 5. And then we invoke a method, double the rectangle dimensions, sending in our object. Here's the method we're going to be invoking. It takes a parameter of type rectangle. It uses the get width method to get out the width. It uses the get height method to get out the height. And then it uses the set size method to double the height and width. And then back in this is going to be in our main method, we print out the dimensions again. So let's trace through what happens here. Okay, here, when we declare our rectangle object, what's stored in the variable rect, it's a memory location to somewhere else in memory where the object is stored, because this is an object. So here is what's actually stored in rect is this arrow, this memory location, this reference to this place in memory. And then we'll print out the rectangle dimensions are 4 by 5. And now we invoke the double rectangle dimensions method. So remember, anytime you invoke a method, what happens behind the scenes is it's like you have code that says formal parameter equals actual parameter. So it's like we have code that says r equals rect. But how does this line r equals rect work? Well, we take the value of what's stored on the right and we put it in the left. What is the value that's stored on the right? It's an arrow. It's a memory location. So let's take that arrow and let's put it in the variable on the left. So now rect and r are aliases. They point to the exact same place in memory. We have not made a copy of this object. There's only one object, but we have two references that point to it. So now inside the method, we declare these local variables width and height, where we retrieve the width and we retrieve the height. Because width and height are integers, we just take the value returned by the getWidth method, which is an integer, and we store it in the variable on the left, width. So it just put the value right in place because these are primitives. Same thing with height. And then we say r.setSize, width and height. So width times 2 is going to be 8, and height times 2 is going to be 10. And we're setting the size of the object r. Well, here's the object r. It's this place here in memory. So let's update the width and the height. Now, when the method is done, the formal parameters and the local variables are garbage collected. So r, width, and height all are garbage collected. But rect still points to the same place in memory. So even though the method is done, and those other variables, formal parameters and local variables are garbage collected, this rectangle is still changed because it was updated at the time when it was an alias with rect. So now when we print out that the rectangle dimensions are 8 by 10, that's why. So when you pass a primitive versus passing a object into a method, it works very differently, even though they both pass the value that's stored in that variable. And the key thing to understand is this idea of aliases. So the formal parameter and the actual parameter become aliases of each other. Now I want to make one other quick point here, and that's if we were to just open up a quick class here. If we were to actually have taken our formal parameter and point it to something else, so if we were to have said R gets a new rectangle, well, now R points to this new place in memory, and rect still points to the old place in memory. So now we've broken that link. They're no longer aliases of each other. So now any change I make to R is only going to affect that new place in memory. This isn't common to see this because usually we want the actual parameter and the formal parameter to be linked. That's why we send an object in, because we want it to be sent in as input for something to happen to that object. So it's not often that you're going to see this happen. But if you do see it, you should know what it means. And this is basically assigning the formal parameter to a new place in memory, thus breaking the alias link between the actual parameter and the formal parameter. But again, this isn't too often that you'll see that. So more often than not, what you'll see is a method invoked on the formal parameter. And then remember that those changes are also made to the actual parameter because it's the same object. They both point to the exact same place in memory. So again, this idea of pass by value and aliases, it's a tricky one in Java, but it's a very important one to understand. And it also tends to be kind of a classic interview question, is explaining how pass by value works in Java. And you should be able to explain how it works for primitives and how that differs for how it works for object references. They're both pass by value, but it works differently because of how Java stores primitives versus objects. Okay, so please post questions about this. Again, it's a very tricky concept, but a very important one.